Just finished up this well tank replacement for a customer. I thought I might just take a minute and explain how these systems work, because some people might not know. So if you live in a house with a well, you've got one of these big, generally speaking, you got one of these big tanks that pressurizes the system and reduces the load on the well pump, which is down in the well. The way that this works is that there's a bladder in here that separates the top half, which is air, from the bottom half, which is water. And so you can think of it as a big balloon in that tank that's pushing against the water. And water's non-compressible, so if you push against it, you're just going to increase the pressure of the system. And so air is compressible. So when the pump pumps water up into the system, it increases the pressure of the system until it reaches 60 psi in the case of this system. So this is a well pump controller switch. And what this does is it monitors with a spring inside of it. It monitors the pressure of the system. This gauge also monitors the pressure of the system, but that's for us humans to read what the pressure is. But there's a spring in here that's set to a specific pressure. And in the case of this system and most typical residential well systems, this will click on. This is just a switch. So there's a line voltage coming in, and then there's line voltage coming out going to the well pump itself. And so there's hot voltage always coming in, and then when this clicks on when the pressure drops below 40 in the system, this will click on and make contact to send the line voltage along and down into out through the pipe that's through the side of your wall and down all the way to the well pump to turn the pump on to say, hey, we need more pressure in the system. And then the pump will continue until it gets up to 60 psi. So the range that the pump operates it within is 40 to 60 psi. And then as you use water in the house, opening faucets and baths and whatnot, the pressure is going to decrease until it hits 40. And when it hits 40, the pump's going to turn back on and crank it up to 60. And so again, the process begins. Now, the purpose of the tank is to make it so that the pump only has to turn on every so often. Because if the pump was turning on constantly, which was actually the problem at this location, which is why we needed to replace the tank, then it's going to burn out pretty quick. The motor and the pump's going to burn out, and you're going to have a dead pump. You're going to have to pull up, a couple hundred feet of wire and pipe and reconnect the pump with a new one. So the old tank that was here, which is this tank over here, this tank had failed. In other words, the membrane that separates the air side from the water side was allowing water through, and so the entire tank got waterlogged, which meant that there was no longer a pressure cushion for the system. So as soon as you opened a faucet, the pump would have to turn on because the well pressure switch was reading that the pressure would go down below 40, so it would tell the pump to turn on. The pump would turn on until you were done using the water, and then you'd shut off the faucet, and the pump would turn off again. So there was no delay, right? So if you open the faucet, you close the faucet, you open it again, the pump's running, it's running and stopping and running and stopping, short cycling. So that's going to burn out the motor real quick. So we replaced the tank. So now we got a new 86-gallon tank here. And these tanks have a rating on them for what's called the drawdown. And the drawdown is just how many gallons per minute you can draw out of the system when you open up a faucet before, basically the capacity of the tank is kaput, and then the pump has to turn on again. So if you have a big house with a lot of fixtures, a lot of people living there, you want a higher drawdown so that you get more mileage out of the water pressure that's being stored in the tank prior to the pump turning on. So those are the main components. Now, This big brass thing here is called the T, the well T, and that goes in and connects to the bottom of the tank, and then it comes out. It's got a bunch of ports on it. This is the inlet port from the well. This is the outlet going into the house, and then you got a drain valve here, and I put in a full port drain valve. In other words, this is 3/4 inch diameter all the way through to this hose fitting here. So all you have to do is put a garden hose on this, open this valve, and you can drain down the system if you need to. This right here is a pressure relief valve. So if the pressure of the system goes over, I think this is set for, what does this say? 75 PSI. The pressure gets above 75 PSI, this thing's gonna pop open and allow water out. And then here we have this, the brass nipple that connects to the pressure switch for the well, and that's what controls when the pump operates. And then you've got your gauge, your pressure gauge, just so that you can come down here and check what the pressure is of your system and make sure it's not too high, too low, whatever's going on. So we have 1 1/4 inch pipe coming into the system. And then the system actually reduces down to 3/4 inch there. So there was no need for 1 1/4 inch here. I piped it in 1 inch up and then reduced it here down to 3/4. And then here's the main shut off valve for the whole house. So if you shut this off, all the house fixtures are above that. So that's how you shut off water for the house. You never want to have one of those shut off valves on the other side of the well T. In other words, I couldn't put a valve anywhere in this pipe here, okay? Because if someone were to turn that valve and shut off the water supply without turning off the electric to the switch control, the well switch, pump switch controller, if the pressure dropped in the system, it would tell the pump to run, and the pump would be pumping, but it would be closed here and it couldn't go pump any further. So that would be what's called deadheading. The pump would be deadheading. In other words, there's a valve closed, so the pump can't pump anywhere. So it's just pumping against nothing, a brick wall. So that's deadheading, and that can also burn out a pump. This piece right here is what's called a check valve or a one-way valve. And that just allows water to travel in only one direction. See, there's a little arrow that shows you which way to install it. And it's gonna allow water through this way, but nothing back this way. And that's important because you don't wanna lose your, on some styles of pumps, jet pumps that are above ground, they need to be primed. In other words, they need to have water in them to function. And so if you were to lose pressure in the system and all the water drops down into the well and out of the pump, then you'd have to reprime the pump, and that can be a long, arduous process. So let's see, that's about it, I guess. There had been one of these Franklin Electric submersible pumps with a motor control to it. That burned out a long time ago, and the current pump that's installed there does not require a motor control. So this is just a glorified electrical junction box with no electronics or motor in it. But this is the motor control that had been in here, but it's no longer connected to anything. I took out the bar with that would connect to those little prongs. So then this is the fusible disconnect. Which is basically just a switch to turn off power to the well if you need to. And it's got fuses, 15 amp fuses. It's a double pole 15 amp circuit. So that's that. And there's an extra fuse up there in case one blows out. Probably should have two, but So that's pretty much how a well tank system works in a residential application. And we're all finished with the job here. So packing up the truck and on to the next one.